This is the third installment of our quadratics, which is day 4 when it comes to what form we're dealing with. The first one was standard, which I was going to scroll back here. There we go. The first form was standard form, ax squared plus bx plus c. Last lesson was factored form, a times the quantity x minus p times x minus q. And today's lesson is going to be vertex form. Vertex form has a very specific form like the other two, unique to itself. A times the quantity x minus h squared plus k. Now, much of it is just like we did before. If a is greater than 0, then the parabola opens up. If it's less than 0, it opens down. Nothing new there. If it opens up, it has a minimum. If it opens down, it has a maximum. The vertex is the max or min point on the graph. And here is where vertex form is nice. Voila. HK is the vertex in our formula. So all we have to do is look at the form and know that if it's vertex form, I know the vertex. And that ordered pair is HK. Remember, the domain is the set of all x values, negative infinity to infinity. The range is the set of all y's. If it's up, then it's bracket y to infinity. If it's down, it's negative infinity up to y, bracket. Okay? The axis of symmetry is the line that passes through the vertex of a parabola that divides it into 2 equal halves. Here is our equation, x equals h. So not only does the vertex form give us our vertex, it gives us our axis of symmetry too, x equal h. Now, I know we're familiar with the solutions, the roots, the zeros. So what are the zeros or solutions to a function where the parabola crosses the x-axis called? Well, the only other term we haven't used in that sentence, and that word is x-intercepts. Okay, so if we have 2, it would look like that. If we have 1, it may look like this. And if we have none, it may look like that. The big key here is HK. All right, the other thing to look at is this. That's minus, that's plus. Very important, okay? So on this particular problem, our A again is 1. What is our H? Since it's in parentheses and it says x minus, this says x plus 3, so H is negative 3. Now what's K? Well, this time it stays with the sign. That says plus K, so that's a negative 1. So automatically, the vertex is negative 3, negative 1. The axis of symmetry is x equal h. The max min value is negative 1. Holy cow, look at this. We're just rolling through it. Domain is negative infinity to infinity. So it opens up, since a is 1, so it has a minimum. Now we better graph it to see what everything looks like. So negative 3, negative 1 is right there. So our axis of symmetry is here. Well, if it opens up, right? If it opens up, it's got to go through the x-axis in how many places? 2, right? Now, we know the range then is going to be -1 to infinity. Has to be, because it's going up. Now, what are the roots? Well, we don't know without our calculator. We have to use our calculator, and I'll probably show you that. I may show you that in class at a later time. I may show you, when we go over this lesson. But there's only one way to find them, and that is to actually use the calculator. Or factor, which is not very easy. So we don't have that capability yet. But we can come up with another point. Pick a point that's close to the axis of symmetry, which is x equal -3. Okay? So how about -2? That's close. So -2 plus 3 squared minus 1. We need to find another point. Well, that's 1 squared minus 1, which is 0. Hey, we got lucky. We just found the root. That was lucky. Okay? -2, 0 is a point right there. So if we mirror that, -4, 0 is the other point. And there's our parabola. But that also found our roots. In vertex form, it's going to be very difficult to find our roots. I'll just tell you that now. We got lucky there. It's -2 and -4. That's not usually going to happen that way. So let's do some more vertex form. Okay? So on number 2, a is -2. H is 1, because it says h minus 1. And k is -5 again. It's negative, so it stays negative. So a is -2, so it opens down. So it has a max. The vertex is h, k. The axis of symmetry is whatever x is. The max value is -5. Domain's easily found, -infinity to infinity. So if we go 1 over 1 down 5, there's the point. And it goes down. So how many solutions would we have? Right, none. We're not going to have any zeros because it's going down. The range then would be -infinity up to our y value, which is -5. Now how are we going to graph this thing? Correct. Pick a point that's close to that point. How about x equals 0? So if we plug 0 in here and evaluate, 0 minus 1 is -1. -1 squared is +1. So -2 minus 5 is -7. So 0, -7 is right there. Oh, axis of symmetry. I forgot that, didn't I? And that reminds us that we can fold it over and find that other point, that mirror point, and there's our parabola. So that's just another way of finding a point. All right, well, number 3 certainly doesn't look like this form, does it? But we can make it look like that form, can't we? So if we go 4x minus 0 squared minus 2, a is 4, h is 0, isn't it? K is -2. So if we just go down the road here, a is up, a is 4, so it has a minimum. Our vertex is 0, -2, so we can graph it. Hey, what do you know? Our axis of symmetry then is 0, x equals 0. Has a minimum value of -2. So we fill in the domain. We can fill in the range because we know we're going up. We also know we have 2 places it's got to intersect the y-axis, or the x-axis. Has to have 2 solutions because it's going up, because that's what we said here. How do we find those? Again, calculator, or we get lucky. Sometimes they'll be decimals. If they're decimals, it's going to be really hard to find. Okay, so I'm just going to pick a point that's close to 0. So let's go 1. 4 times 1 squared is 4 minus 2, right, which is 2. So 1, 2 is a point. So if we mirror that over to the left, we end up with this skinny little parabola. Now there is no way to find those solutions without using our calculator or having more knowledge. So what are the solutions? I don't know. One of them's negative, one of them's positive. But I don't know what they are. I'd have to use my calculator, or I have to know how to factor number 3, and we haven't factored yet. That's still to come. Okay? Last one. A is negative 1. K is 0, isn't it? There's no K out there. And H is negative 3. Again, A is negative 1. It opens down, so it has a maximum. HK is our vertex, negative 3, 0. Axis of symmetry is x equal whatever our x is. In this case, it's negative 3. Our max value is 0. Our domain, our range would be negative infinity up to 0. So we're going to have one solution, aren't we? Negative 3, 0. So our x is negative 3. So we've got everything but a graph. We just filled it in, but we don't have a graph. So we got to pick a point that's close to negative 3. Well, we could pick 0. Let's see if 0 will fit on there. Oh yeah, it will. 0 plus 3 is 3. 3 squared is 9. Negative 1 times 9 is negative 9. So 0, negative 9 is there. 1, 2, 3, 1, 2, 3. We're going to mirror it to the other side. And there's our parabola. And this concludes the graphing of quadratics.